Hi, hello, welcome back to ASMR tutorial once again. So, in this session, we are going to discuss about complex Fourier transform problems and its solution. In the last class, we have discussed about basics of Fourier transform and few properties on Fourier transform. So, with the help of all those, we are going to solve few problems on Fourier transform. So, I have taken one simple example here. You can see, you can read the statement. Find the complex Fourier transform of the function f of x equal to 1 for mod x is less than or equal to a and 0 for mod x is greater than a. And also they are asking us to evaluate the integral 0 to infinity sin x by x into dx. Okay, so this is our problem. First we have to find out Fourier transform, then we have to evaluate this integration with the help of Fourier transform answer. Okay, we'll go for the solution part. So first we have to write the definition of the complex Fourier transform. So what is the definition of the complex Fourier transform? In the last class we have discussed already. We'll write that definition of the complex Fourier transform. So that is f of u equals to integral minus infinity to plus infinity f of x e power iu x into dx. So if we write this formula in the exam, we will get 1 mark for this. Then we have f of x value, and you can see here this is one f of x value, this is another f of x value they have given. So this f of x, I'll simply write one normal graph. F of x value lies between minus a to plus a. So this is minus infinity to plus infinity. If I consider minus a somewhere come here, plus a somewhere come here. Okay. So in all other cases the value is 0. Only from minus a to plus a the value is 1 as per the given data. Okay. So now if I rewrite this f of u with the help of the given statement, so what happens? F of u equal to integral minus a to plus a, because you can see here the value of f of x is 1 when mod x is less than or equal to a. So minus a to plus a, 1 into e power iu x dx. Okay. Now we have to integrate this simple term. We know the integration of e power ax dx. So what is integration of e power ax dx? E power ax by coefficient of x, that is a. The same way e power iux with respect to x. So e power iux divided by coefficient of x is what? Iu. So between the limit minus a to plus a. Then we have to operate upper limit and lower limit both for this function. This iu is free from x, so I'll write that outside, iu outside. Then we left with what? This part, that is e power iu x between the limit minus a to plus a. Then if I substitute upper limit in place of x, lower limit in place of x, we'll have this term, that is 1 by iu into, so that is e power iua minus e power minus iua. So we know that e power I theta. What is e power I theta? Cos theta plus I sin theta. Similarly, minus I theta means cos theta minus I sin theta. It is of the form e power iu. So if I operate this formula for this term and this term, so what will have? We have f of u equal to 1 by iu into e power iua. So it becomes cos au plus I times sin au. In the same way, if I write this term, that is e power minus iua, so that is what happens, cos au minus I times sin au. So here plus cos AU minus cos AU will cancel. Minus into minus plus. So what we have? F of u equal to 1 by u into I sin A minus into minus, this become plus. So I sin A plus I sin A, it becomes 2 times I sin AU. So here this I cancel. We cannot cancel this u and this u because this u is under function, this u is free term. So you can't cancel this u and this u. Okay. So what happens? Finally, we have sin AU by u and 2 is also there, that is 2. Therefore, Fourier transform of the given problem is 2 times sin AU by u. So this is our required Fourier transform from the given statement of the problem. Then from this we have to evaluate this integral part. That is, we have to find out integral minus infinity to plus infinity sin x by x into dx. How to evaluate that? So to evaluate that, we are supposed to use inverse Fourier transform. So we know that inverse Fourier transform. So what is that? Inverse Fourier transform, f inverse of f of u or f cap of u. So this is nothing but f cap of u and f of u both are same. So we know definition, write the definition. So what we have, that is 1 by 2 pi integral minus infinity to plus infinity f of u e power minus iux into du. This is nothing but our f of x. Okay, so we know f of u from here. You just substitute that f of u in this part. So what happens? 1 by 2 pi integral minus infinity to plus infinity f of u value I am substituting from this step, that is 2 times sin AU divided by u into e power minus iux is there. So e power minus iux as it is into du. This becomes into du. So then if we simplify it further, so what happens? F of x, this is the answer, f of x equal to this 2 and this 2 will cancel, that is 1 by pi integral minus infinity to plus infinity sin AU divided by u e power minus iux into du. So now one part of the problem is got over now. Here I'll just erase one side part, this I don't need, so I'll erase this. Then we have to continue the problem further because we have to evaluate that integration part. See, the beauty of this Fourier transform concept is that only without actually integrating the function, we are using the concept of Fourier transform and inverse Fourier transform. We are finding the solution of the given integral part. So that is one of the important application as well as beauty of Fourier transform. Now I'll just write this and this f of x here. So f of x equal to what we got, that is 1 by pi integral minus infinity to plus infinity sin AU divided by u e power minus iux into du. Now what we are supposed to prove? We are supposed to prove this part, that is minus infinity to plus infinity sin x by x into dx, its value we have to find out. Okay, so that how to find out? See, this we have to find out minus infinity to plus infinity, here limits are also same, but in place of x we have u terms here everywhere, and this e power minus iux term is not there in the deduction part. So we have to eliminate this. How to eliminate? It cannot become 0, not possible, because it becomes 0 0 into something 0. So only option is it should become 1. Now for what value of x this term becomes 1? Only option is x equal to 0. That is the reason we will consider let x equal to 0. When we take x equal to 0 value in this above substitution, so what happens? F of x, so f of x equal to, that is 1 by pi integral minus infinity to plus infinity. You can see this term contain, no x. So there is no x in this term. So that term will be written as it is. That is sine au by u, and this term, that is e power minus iux, it becomes 0. E power minus iux becomes e power 0. E power 0 value is what? 1. So that is du. Then what happens if I simplify it further? This minus infinity to plus infinity, it becomes 0 to infinity, because in the problem we have 0 to infinity sin x by x into dx. This we have to find. So minus infinity to plus infinity we have here. So this we have to simplify further, minus infinity. How to simplify it further? Using the even not concept. So properties of integration we know. So use that properties of integration. What does that says? We know that minus a2 plus a f of x dx equal to 2 into integral 0 to a f of x dx if f of x is even function, otherwise it becomes 0. Now if I consider this part, this whole term becomes f of u. Okay, so this we will simplify. I'll just erase this. Now I have to simplify it further. That is f of x becomes 1 by pi becomes 2 by pi, integral minus infinity to plus infinity becomes 0 to infinity, that is sine au by u into du. Why? Because our f of u is sine au by u. If I replace u by minus u, what happens? It becomes minus sine au divided by minus u. Minus minus cancel. After replacing minus u in f of u, I am getting positive of f of u. Therefore it is an even function. For even function, the limit minus infinity to plus infinity becomes what? 0 to infinity sine au by u into du. Okay, so this we are almost similar to the deduction part. So what happens when we take x equal to 0, the f of x also we have to find out. F of x 0, where it lies between minus a2 plus a, in between that term 0 we have. So for that minus a2 plus a, the functional value is what? 1. You can see the problem statement here. F of x is 1 for minus a2 plus a. From minus a2 plus a we have 0 term. So therefore 0, the function is 1. So therefore this f of x becomes, this term becomes 1. So 1 equal to 2 by pi integral 0 to infinity sine au by u into du. And if I simplify it further, this 2 by pi, if I shift to the left hand side, it becomes pi by 2 integral 0 to infinity sine au by u into du. Now you can see here this term says sin x by x 0 to infinity. So here a is the extra term. We have to eliminate that a. So simply you just put a equal to 1. If we put a equal to 1, then we'll have pi by 2 equal to integral 0 to infinity, and u is there. You just replace u by x. No change. So it becomes sin x by x into dx. So this is how we are evaluating this particular integral using Fourier transform without actually integrating the function. So as I told, it is one of the important applications of Fourier transform, as well as this is the beauty of Fourier transform also. So let's do one more problem based on the Fourier transform only. Okay, so that you will get much more concept or much more steps how to solve this problem. Okay, so let me take one more problem with respect to this. See, Fourier transform is one of the important topics in engineering mathematics. So those who are good in Fourier series concepts, they can easily find out Fourier transform problems also simple. Okay, so you can see here this is one more important problem in Fourier series. So what it says problem statement says if f of x equal to 1 minus x square if mod x is less than 1 and 0 if mod x is greater than or equal to 1, find the Fourier transform of f of x and hence find the value of integral 0 to infinity x cos x minus sin x by x cube into dx. So this is the problem statement. Okay, so for this statement we have to find out the solution. So how to find out the solution? So as usual, first thing we have to write the definition of the Fourier transform. So the required Fourier transform is given by what? F of u equal to integral minus infinity to plus infinity f of x e power iux into dx. Yes, you call it as equation 1. Now, when you see this particular problem statement, what it says, f of x value is only 1 minus x square when x lies between minus 1 to plus 1. In all other cases, it is 0. In all other cases, it is 0. So, f of x value is 1 minus x square when x lies between minus 1 to plus 1. In all other cases, the function value is 0. The function value is 0. Just change this inequality. This is less than or equal to, this is strictly greater than 1. Now, based on the statement of this particular problem, I'll rewrite f of u. F of u equal to minus infinity to plus infinity. I'll just interchange the limits because you can see the value of this f of x is 1 minus x square when x lies between minus 1 to plus 1 from this particular point. Okay, so minus 1 to plus 1, f of x value is 1 minus x square e power iux into dx. So now if I integrate this by parts method, because simply I cannot integrate, we have to integrate this by parts method. So we know that integration by parts u into v dx. How? U integral v dx minus u dash double integral v dx dx plus u double dash triple integral v dx dx dx. This is called general method or Bernoulli method for parts method. So for this I'll just treat it as u, for this treat it as v. Okay. So if I operate this, so what happens? F of u equal to first function 1 minus x square as it is. Here 1 minus x square as it is, then e power iux integration. You see here u is 1 minus x square and integral of v dx means e power iux. Integral of e power iux dx minus differentiation of 1 minus x square is minus 2x into double integration of e power iux dx dx plus into minus minus, or you just write plus minus 2x differentiation is minus 2 and triple integration of e power iux dx 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 plus 2 differentiation will be 0, 0 into something 0. So if you don't write also, no problem. Okay, So minus 1 to plus 1. Now I'll simplify it further. F of u equal to 1 minus x square integral of e power iu x dx, e power iu x by iu, and minus into minus plus 2x. See, double integral of e power iu x dx is that. So one time integration of e power iu x dx we got, that is e power iu x by iu. This we have to integrate one more time, that is e power iu x divided by iu whole square. So this term over, then minus into plus minus 2, triple integral. So in the previous step we have double integration. If we integrate this term once again, we will get triple integration. So e power iu x divided by iu whole cube. So between the limit minus 1 to plus 1. Now if we operate these limits for the each functions, this and this, what we will get, we'll see. Before that, you just know this I square value is minus 1, then I cube value I square into I, that is minus 1 into I, that is minus I, then 1 by I value is also minus I, because if you multiply denominator with I into I, simplify, will get minus I. So if we operate limits for the this particular minus 1 plus 1, if I operate 1 minus 1 whole square 0, if I take lower limit also, minus 1 whole square is plus 1, 1 minus 1 0. So for both upper limit and lower limit, the value of this particular function is 0. Okay, now this is 2, second term is this. Okay, this is our second term. This we have to operate limit minus 1 to plus 1. So I square is there, I square value is minus 1, minus into plus minus, that is 2 by u square. If I operate upper limit as well as lower limit, it becomes e power iu minus of minus 1 e power minus iu, because x is 1. When you operate plus 1, 1 into this, x lower limit minus 1, minus 1 into this, that I have written. Then the last one, this particular term we have to simplify, minus 2 by I cube u cube, or this 1 by I cube is nothing but I only. This we can write it as here itself, no problem. Then upper limit is plus 1, that is e power iu, lower limit is minus 1, e power minus I. So if we simplify this, so what happens? F of u equal to minus 2 by u square e power iu minus into minus plus e power minus iu minus 2I by u cube e power iu minus e power minus iu. So this is one part of the simplification. This we have to simplify further. I'll just erase some parts here. So we have to simplify this further. So before simplifying this further, I'll just take the value of e power iu, e power minus iu. Okay. So I'll just consider, we know that e power iu. What is e power iu? Cos u plus I sin u. E power minus iu, cos u minus I sin u. If we add and subtract these two terms, we will get this term, we will get this term. That is e power iu plus e power minus iu. When we add them, the sign terms will cancel. It becomes 2 cos u. And if we subtract them, cos term will cancel. We will get this term will cancel, we will get sine terms. Okay, when you subtract them, these two will cancel, sine terms, sine 2 times I sine u. So therefore if we substitute this in f of u, so what happens f of u now? Therefore f of u equal to minus 4 times cos u by u square plus 4 sin u by u cube. Or if I simplify it further, f of u equal to 4, if I take common, so it becomes sin u minus cos u into u, because I'll take u cube as LCM. Since this term don't have u cube, so u will come here, u cos u. So this is our f of u. From this f of u we have to evaluate the given integral, this particular part. We have to evaluate this particular integral. Okay, just erase this and we'll solve that. Now, so to evaluate the required, this is second part, we need inverse Fourier transform. That is, inverse Fourier transform is nothing but f of x is nothing but f inverse of f of u. We have the formula. So what is that? Minus infinity to plus infinity f of u e power minus iux into du. So in the previous step we have f of u here, substitute. Therefore f of x equal to minus infinity to plus infinity sin u minus u times cos u divided by u cube into e power minus iux into du. So this is very important step. Now you can see here, on comparison of the given problem and this particular result, e power minus iux is extra term, so that has to be 1. So how to make it 1? Only option is by taking x equal to 0. So okay, this has to be 1. So let x equal to 0. If I take x equal to 0, you have to check f of x also. So x equal to 0, where it is there, x lies between here. So if I take x lies between here, the function is 1 minus x square. So 0 square 1, f of x becomes 1. Therefore f of x, that is 1 equal to minus infinity to plus infinity sin u minus u cos u as it is divided by u cube as it is into this e power minus iu 0 becomes what? 1 into du, and we have 4 also. This 4, so we are not supposed to forget 4. I'll write here into du. Next, again use even odd concept to change this limit minus infinity to plus infinity, 0 to infinity. So if I operate even odd concept for this, so clearly this function is an even function. This function is an even function. So what happens? Therefore 1 equals to 4 into 2, 0 to infinity sin u minus u cos u divided by u cube into du. Okay, so what happens if we simplify it further? uh, Here one more thing we have to observe. So what is that? In inverse Fourier transform, I just forgot and write that 1 by 2 pi. Where is the definition of inverse Fourier transform? Now this is 1 by 2 pi will come here. So I've forgotten. So 2 pi. 1 by 2 pi. So it should come. So if I write that, 2 will cancel. So what happens? If I simplify it further, this becomes 5 will goes here, 4 will come here, 5 by 4 integral. I'll take minus sign outside from this, minus integral 0 to infinity u cos u minus sin u divided by u cube into d. Why I have taken minus sign from outside? Because here it is x cos x. In the problem statement, we need to simplify x cos x. So here it is sign is there, that is the reason I have taken minus out. Then you just replace u by x. Therefore, integral 0 to infinity x cos x minus sin x divided by u cube into dx. Answer is minus 5 by 4. So this is how we are going to simplify the Fourier transform problems, and with the use of Fourier transform and inverse Fourier transform, we are evaluating the most of some complicated integral problems also. Okay, so I hope you enjoyed this session. So thank you all. We can meet with the next video.